Hello everyone, welcome back to Let's Unbound. So we are in another new episode of AP Precalculus, concept review plus problem solving. So this is about 1.2.13 exponential and logarithmic equations and inequalities. Let's get into the topic. So first, solving logarithmic equations. We have many types. So let's see. The type 1 is very simple. Log with base b f of x equal to log with base b g of x. So like two functions, but the log is on both sides with the same base. So in that case, it's very simple. Like it implies f of x equal g of x. It will become a normal equation and you know how to solve this, right? Then type 2, a constant like k plus log b f of x and other side also log b g of x. Our aim is to get rid of the log, right? So you can, so with this k, you can just rewrite k as k into log bb because we know this value is 1, right? So we can rewrite it and then we can follow. So like after this, k log bb plus log b f of x equal to log b g of x, right? So now this k will go here, correct? As per the rule, power rule. So log b power k, log b f of x equal to this. So now my aim is to make a single log. So log b, this addition, right? So when you condense it, it will become multiplied. B power k f of x and equal to log b g of x. I actually now arrived at the like kind of type 1. Both sides we have log with same base, so this will be equal. B power k f of x. B power k is just a number, right? Into g of x. Okay, that's the goal. And type 3, a constant time exponential form. B power f of x equal to another constant. So first you group the constants. Like this goes here, k2 by k1. Take log b on both sides. Okay, we want to get rid of that. Like, why we are doing this? Because function is at the exponent place. I should get it to the normal place. So take log b. Whatever your base, take that log with that base. So it will actually bring your exponent function to the normal position. So log b power f of x, but you should, whatever you do it on both sides for balancing. Log b k2 by k1. Now, as per the power rule, you can write f of x in front. F of x log bb. We know it's 1, right? So just it's f of x on left side and right side it's log b. This is just a number, right? And you can solve the next. And type 4 is like some complicated equation. We can directly use Desmos if it's a calculator active problem, right? So now these are the types. And now solving logarithmic inequalities type 1 and type 2. Log b f of x is greater than a constant. So first I will raise to the whatever your log have a base. So raise it to the base b on both sides. So when I raise like b power log bx, b power k, right? So this b and log b, they are inverse, so they will get cancelled. You will get f of x greater than b power k. But raising b, your base is very important and it will seriously affect the inequality sign. So f of x greater than b power k. If your b is greater than 1, then the sign will follow as it is. Whatever inequality has, after raising also, it will be the same. And why is this f of x greater than 0 comes up? Because your logarithmic thing would be, so whatever like we are giving here as an input should be positive, like the basic log fact. And case 2, what if it's 0? It's not minus, actually, it's a hyphen. 0 to 1. F of x greater than 0, that is for sure, right? That is the basic logarithmic thing. But the inequality sign will flip. It was greater, but I'm raising to the base b, which is between 0 and 1 means the inequality will flip. Okay. So now other cases, log b f of x less than k, same, raise log b on both sides, and we got this. And this is important. When b greater than 1, we will get the same inequality. When your b is lesser than like between 0 and 1, it will be flipped. So whatever your original, it will be just opposite for this case. Right? And of course, f of x greater than 0, it's a mandatory condition. F of x means here input. Now, type 3, we have this exponential inequality, b power, but the solving will include log. B power f of x greater than k, so I will take log b on both sides. And we got it. Then f of x will come print f of x greater than log bk. Log bk, it's a pure number, right? And these are the types in solving inequalities. So now, the most important thing is about inequality direction rule. If b is greater than 1, then if we have a greater than c, yes, you can take a log on both sides. But if your base is greater than 1, same greater than follows. If your base b is between 0 and 1, it will be flipped, right? And graphically also we can just give the, like solve the inequalities, like two functions will graph, like e power x and e power 2x something. So if you have like first function is less than second function, we will pick this interval, right? Something like this. So we can do graphically also. Now, next is inverse of log and exponential function. We know inverse of log is exponential, inverse of exponential is log. But let's see what is the procedure to find for general, some example functions I have here. So as usual, first you should write in this form y equal to 2 power x minus 10. Then you have to switch the variables. X is equal to 2 power y minus 10. And then you should make y as a subject, right? So what should I do? You add 10 on both sides. This will get cancelled. X plus 10 equal to 2 power y. I should bring y to the normal place. So I will be taking log with base 2 on both sides. Right? So log with base 2 x plus 10 equal to log with base 2 2 power y. Now your log has an input which has a power. You can apply the power rule. So it's y log 2, which is just y. And we got this log 2x plus 10. This is your inverse. This y you can change into f inverse of x. Right? So we started with an exponential. The inverse ended with a log. Of course, it will end with a log. Right? Now, starting with the log function and finding inverse of it, same process, y equal to log 1/3 minus 3x. Right? Now, switch the variables. X is equal to log 1/3 minus 3y. Now, we need to make y as a subject. First, I should take the log to the other side. It will become exponential. Like exponential basis, whatever the log base. So 1/3 whole raised to the power x. It's not x power 1/3, okay? Base will be 1/3 equal to minus 3y. And I need just y, so I will take the minus 3 to the other side. So it's minus 1/3, 1/3 x equal to y. So now you can simplify or you can leave as it is. Let's simplify this. So minus 1 power x is 1. So it's 1. 3 power here 1, here x. So 1 plus x equal to y. And you can change this y to f inverse of x. Finally, minus 1, 3 power 1 plus x. So this completes this particular. Now let's solve some questions. Solve ln x plus 3 equal to ln 20 minus 5x. First aim is to make both the sides having ln. So here you can just apply the product rule, ln x and ln x plus 3. So you can combine x into x plus 3 equal to ln 20 minus 5x. So ln x square plus 3x equal to ln 20 minus 5x. We know this, right? If ln a equal to ln b, then a equal to b. So we can do that. X square plus 3x equal to 20 minus 5x, and you will get a quadratic. So x square minus 5x will shift there, and it's 8x, 20 will shift there, minus 20 equal to 0. Now we need to solve for what is x, and most importantly, log has input restrictions, like it can be only x greater than 0. So we should be careful with that. So make it as product, and product we need minus 20, sum we need 8. 1 times 20, no. 2 times 10, yes, there might be a possibility. And we can give a negative for this. So yeah, it suits. So x is equal to positive 2 or x is equal to negative 10. So your ln has x always greater than 0, right? So this is here x plus 3 greater than 0. That is x greater than minus 3. So when I put 2, everything will satisfy. When I put minus 10, only the right side will be satisfied, other will not. So combinedly, the restriction, the x would be minus 10 is not applicable, right? And x is equal to 2 is the only solution here, right? So we should filter out which is not a solution in this case, like in case of logarithms, right? And moving to next part. Solve 5 into e power 2x plus 4 minus 8. It's an exponential equation. So let's be pure exponent form. Other thing you can just like add 8 on both sides. 5 e power 2x plus 4 equal 8. Then divide 5 on both sides. 5 cancel. E power 2x plus 4 equal 8 over 5. Now I want to get rid of this e. For like e means it's a ln is the reciprocal function, like I mean inverse function. So take ln on both sides, and ln and e will be cancelled, or you can write 2x plus 4. Ln and e makes 1 because ln e is 1. Why? Ln means log with base e. So if your base and input is same, it's 1. That's the case I put there. Okay. So now equal to ln 8 by 5. And we need to solve for x. So 2x equal to ln 8 by 5 minus 4. X is ln 8 by 5 minus 4 by 2. So this is the only x value we got here. Right, and that's simple. Now let's move to question number 3. It is a question for on inequalities. Log 3x minus 2 plus log 3x is greater than or equal to 2. Maybe let's go for, okay, let me change this a little. X minus 2 and x plus 2. So then 5 over 2x minus 1 is less than 3 over x plus 2. So let's solve this first part. So I'm changing this to x plus 2. Okay, how to solve? Now it's log 3, x minus 2 and x plus 2. So product 2, right? So when you condense, they will become product x minus 2 into x plus 2. Greater than or equal to 2. So simplify log 3, x square minus 4. Greater than or equal to 2. Now, log 3 when you shift to the other place, and I'm raising to the base, so inequality will not change. X square minus 4, it will become 3 square. 3 base and it's an exponent form. So x square minus 4 is greater than or equal to 9. And when you write x square minus, like when you shift the 9 here, minus 4 minus 9 minus 13 greater than or equal to 0. Now factorize, because it's not just a simple inequality, it's a quadratic. So if you factorize, it's x minus root 13 into x plus root 13. How? Here. So x square minus 9 means what will you do? 9, you will replace it as 3 square because it's a perfect square. It's not a perfect square, no problem. But still, you have x square minus something means you can just put a square root of it and square it. Right? That's the case. So x square minus 13, I write it as x square minus root 13 the whole square. So that I can easily apply the property. Now, now write the number line and write your numbers. So minus root 13. From this 0, if you solve, it's minus root 13. Here it's root 13. And find the signs. It's quadratic, right? And it's a downward facing quadratic. So for sure, here negative because it goes down. here positive, here negative, and we are picking for positive and also included. So we have to include these values. So for root 13, it's it's an upward facing parabola. I got confused. So actually it's an upward facing parabola because of it's having a positive leading coefficient, and it will be positive, negative, and positive case, like here minus root 13 and root 13. So I want only positive and also included when it's 0 means where it crosses. So here to here. This is positive and this is also positive. But our input is dealing with log. This minus root, right, negative values, right? Yes, it shows it will give positive answer, but first of all, these inputs will not work, right? You put some -5 here, it will collapse, right? So we can't use this. So only the minus x greater than or equal to root 13 in interval notation can write it's from root 13 to infinity, right? So now let's move on to next part. 5 power 2x minus 1 is less than 3 power x plus 2. You can easily solve it in Desmos. Let me tell you how to solve it analytically, like in an algebraic way. So first you can write, let's get rid of this power form. So I should take log on both sides and taking natural log. Log with any base is fine. So I'm taking this log 5 power 2x minus 1 is less than log 3 power x plus 2. The inequality will not change. Why? Log means log with base e, and this is 2 point something, which is greater than 1. That's the reason. Now, so ln or log have some input, and it has a power, means you can write it like 2x minus 1 times ln 5. Okay, ln 5 is a number less than x plus 2 ln 3. It's a number. So we should be careful here. Then you can multiply. So 2x and then ln 5 minus ln 5 less than x times ln 3 plus 2 ln 3. Right? Now let's group x together. So this. So 2x ln 5 minus x ln 3 is less than 2 ln 3 plus ln 5. Now 2x, okay, I think we can take x common out and we will have, okay, so let it be x. I can put ln 5 the whole square minus x ln 3. We can write x ln 5 square like this minus x ln is less than ln 3 square plus ln 5. So we did some manipulation using the power rule. And now we can solve it here. You can take x common out of this. And we got ln 5 square minus ln 3 is less than. So ln is added. So using a product rule. Okay, let's go ln 3 square plus ln 5. So x is less than ln 3 square plus ln 5 divided by ln 5 square minus ln 3. So if it's an exact form, you can leave it, or we can apply calculator. But we can simplify it furthermore. Ln 3 square by 5 divided by ln, 3 square times 5, because the numerator is expanded log in addition. So 3 square times 5, denominator expanded log in subtraction. So ln 5 square by 3. And you can solve for it. Don't write like ln cancel. So you have to give the values, and it will be approximately, I have it somewhere. Yeah. 1.795 something. Or you can leave it in exact form or to three decimal places. And that's the thing. Now, we are moving for, yes, bonus question. Bonus question is completely on finding inverse. So yes, find inverse of these following functions. And that's the wrap for today's video. Thank you so much for joining today. I will be meeting the next video very soon. Until then, keep learning, keep practicing. And very soon we will be starting Unit 3. So make sure to subscribe and save this playlist for future reference.